All right, we're ready for section 12.2, the mole. Here's our objectives. Be able to express the value of Avogadro's number and explain its relevance to moles. Use that number to convert to number of particles and vice versa. And use the molar mass to convert to grams from moles and vice versa. There are a lot of words that refer to numbers that mean things, like pair means 2, or dozen means 12. Some maybe less common ones, but words that mean things. Gross means a dozen or 144. Score, equals 20, 4 score and 7 years ago. These are all just words that mean numbers. And so is a mole. When we refer to a mole in chemistry, we are simply referring to a number, a very large number, because we're talking about very small things like atoms. And that number is 6.02 times 10 to the 23rd. You need to know this number. This is one of those things you should memorize. 6.02 times 10 to the 23rd. It's named after, Avogadro's number is named after Amedeo Avogadro, kind of a handsome looking guy there. He didn't ever actually calculate the number. He did a lot of calculations with gases and did some different things, but they named this number after him because of his work with that. And sometimes you'll see it as a capital letter N. We won't probably use it all that much that way. All right, so if you measure out the atomic or molecular mass, depending if we're talking about atoms or molecules or whatever, of a substance in grams, you always have this many particles. Assuming that you could measure it out perfectly, that's what you have. So for instance, if we're talking about calcium, and if you look up the atomic number of calcium, it's 40.08. So if you measured out 40.08 grams, so on a periodic table, those are AMUs or Daltons or whatever. But if we did it in grams, then we would have this many particles. Or if we looked up, let's say, potassium, and you looked up potassium, and you would say, oh, well, on the periodic table it is 39.098. If I measure out 39.098 grams, I will have that same number of particles, 6.02 times 10 to the 23rd. So here's the definition. That's probably a little more confusing than what we were just talking about. But they're saying if I have 1 mole, exactly a mole of carbon-12, carbon-12 is kind of our standard, it would have a mass of 12 grams, and it would contain exactly 6.02 times 10 to the 23rd atoms. So that's what they're defining Avogadro's number as. All right, let's talk about molar mass, and this is kind of the same thing that we did yesterday. It's just, finding formula masses or atomic masses. We're just talking about the mass of a mole of a substance, whatever we've got. So if we have 1 mole of water, it's 18 grams. Remember, water is H2O. 2 times 1 plus 16 equals 18. Okay, and it has 6.02 times 10 to the 23rd molecules in it. So 1 mole of any element or compound has a mass equal to its molecular mass in grams, contains 6.02 times 10 to the 23rd particles. So if I want to say, hey, I have a mole of calcium atoms that we were just talking about, you would have 40.08 grams of calcium atoms, and you would have 6.02 times 10 to the 23rd calcium atoms. Okay, that's what they're saying. A mole has a mass equal to its molecular mass, but we just do it in terms of grams instead of AMUs or Daltons, and it contains 6.02 times 10 to the 23rd particles. All this stuff we call the molar mass. So let's talk about converting, because that's kind of what we need to be able to do. We need to be able to convert things back and forth. So the mass of a single molecule of H2SO4 is 98 Daltons. Remember, Daltons and AMUs, same thing. This is the newer term. And remember, that would be from 2 times 1 plus 32 plus 4 times 16. That equals 98. So if we had just one molecule, it would have 98 Daltons, really, really small amount. Okay. So the mass of Avogadro's number, in other words, if we had 6.02 times 10 to the 23rd of those molecules, we would get the 98 grams. Here's our number, 98 grams. So what if we wanted to figure out how much did one single H2SO4 molecule weigh in terms of grams? Well, we said that it's 98 grams for a mole, and there's this many molecules in a mole, so if we took 98 divided by 6.02 times 10 to the 23rd, we would get the mass of one molecule, 1.63 times 10 to the negative 22 grams. Now, we have no way of measuring this. We don't have a scale that's that accurate in the world, but that's how much it would be if we did. All right, let's do an example here. And this is kind of the key to what we want to do in this section. We want to be able to convert. So the question is, how many molecules are there if I have 0.001 mole? So I'm just saying molecules. It doesn't tell me what, but I don't really care, because I always know that in 1 mole there are 6.02 times 10 to the 23rd molecules. So what I need to do, this is, go back to our factor label method that we did a long time ago. We're going to do this now a lot, so be ready for that. So I'm saying, hey, how many molecules do I have if I'm given 0.00100 moles? Here's my conversion factor. I need to set it up as a fraction, and I want to make it so that moles will cancel. So I need to put 1 mole on the bottom and 6.02 times 10 to the 23rd molecules on the top. So when you do this, make sure that you remember how to punch in the number on your calculator, because everyone, these calculators are different. Then you're probably using that EE key or the EXP key. And when you do that, you're going to take 0.001 times 6.02 times 10 to the 23rd, and you should get 6.02 times 10 to the 20th. All right, here's another question. How many moles would we have if we had 108 grams of water? All right, so set it up. We're trying to find moles. I always put my little question mark, moles, question mark, moles, equals, what am I given? 108 grams H2O times, put my little line, and now I got to figure out my factor here. Well, here it is. If I have a mole of H2O, it is the molar mass of H2O, which is 18 grams. So there's my conversion. There's my factor between those. I just want to set it up in such a way that my grams will cancel and I'm left with moles. So I'll put moles on the top. 1 mole H2O over 18 grams H2O. Grams will cancel. Okay? So I'm going to take 108 divided by 18, and I would get 6 moles of H2O. Alright, here's another example. What is the mass of 7.50 moles of CaO? So what are we trying to find? Well, we're trying to find mass, and we're given 7.5 moles. So set it up, make your fraction. Here's my conversion, 1 mole, 56.1 grams. Want to make it so that I end up with grams, so grams are going on the top. 56.1 grams CaO, 1 mole CaO. Get used to putting in those labels, and even include the label for the substance, because eventually we will be changing substances. That'll be part of what we have to do. So go ahead and write that out. Even though it's a little more writing, you can handle it. If we multiply that out, I got 420.75. Alright, it's your turn. Stop the video, do these 2 problems, and then start the video again and see if you did them right. Alright, so here's your answers. You can see that if we take 60 grams of sodium hydroxide, our molar mass is 40. So we're going to divide by 40. We're going to get 1.5 moles sodium hydroxide. On the next one, we're setting up how many moles given 2.73 grams. And here's our conversion. 1 mole is 53.5 grams. Looking that up on the periodic table. And set up that ratio and do this. When you do these, you need to have all of these steps. On the test, I'm looking for each step in the answer. You know, you have all of those, so you get a point for getting each of these steps. And these are simple one-step problems. Eventually, we'll be doing three-step problems. So you need to make sure you understand the one simple steps before you go on to the other ones. All right, here's a couple more. Stop the video, do these problems, check it out when you're done. Alright, so here's our answer. If we're trying to figure it up, once again, set it up so grams equals what we're given, 0.1 moles. And I did this a little different, and this is just kind of the way I've done it to kind of save some space all the time, instead of writing out the equivalents down below. This is my equivalent thing. 1 mole equals, you know, all of this. This is my molar mass, the 12 grams for carbon, 2 times 16 for oxygen, and that totals 44. So a lot of times if I don't know it, I just kind of write it above that line and make it all part of that fraction. You don't have to do it that way. I just wanted to show you this a little bit differently. So you're going to take 0.10 times 44, 4.4. Same thing on this one. Trying to find grams, given 0.437 moles. Here it is, 40 grams is what that is for my molar mass, 1 mole NaOH. So 0.437 times 40 gives me 17.5 grams sodium hydroxide. Alright, one last one. Do this one. How many molecules are there if I have 0.250 moles of H2O? So once again, stop the video and do this problem. Alright, so here it is. We're setting it up so that we're trying to find molecules H2O given 0.25 moles. Here's my conversion. 6.02 times 10 to the 23rd molecules per mole. Make it so that moles will cancel. So you cancel out your moles. You're left with molecules at that point. Total answer 1.505 times 10 to the 23rd. You know, you would find that for this one, it's not going to change depending on no matter what you have, because for particles, it's always 6.02 times 10 to the 23rd. So it wouldn't really matter if we had water or sodium hydroxide or anything else on this one. Alright, so that's it. We'll see you later.